So today we have to see what? We have to see the cathode ray oscilloscope. Okay, cathode ray oscilloscope. But before seeing cathode ray oscilloscope, let me show you the diagram of CRO. So this is actually the CRO. Okay, so it has lot of different components. The main component is this. Can anyone tell me what is this? This component? What is this component known as? So this
Like,
component is, हाँ बोलो, tell.
it emits electron.
It emits electron. So is it an electron emitter? So there is a specific name for this. So this is basically a cathode ray tube. Okay, cathode ray tube. Now, where have you seen this cathode ray tube? Let me tell you, cathode ray tube it used to be in your this television set if you have seen. Okay, there used to be this big conical means screen was there like this. This is the front view I am showing. Means this, if I show you the side view, you have seen. So this used to be the shape of TV. Inside that television set, there used to be this cathode ray tube only. Nowadays we have LED, LCD TVs, okay? But if you go back like 20 years ago, this was the television set, bulky television set. In that also, this cathode ray tube was used. So the main heart of this cathode ray oscilloscope is CRT, which is also known as cathode ray tube. So first we are going to start with what? We are going to start with cathode ray tube, and eventually we are going to come to this cathode ray oscilloscope. Okay. So what purpose, let me ask you, CRO, what purpose does it serve for? What can we do using CRO?
We can plot various signals.
Okay, it can plot various signals. Another, anything?
So measurement of voltage, frequency.
Okay, very good. So it can display various signal. Display different signal like mainly sinusoidal. Okay, then your the sawtooth waveform. Sawtooth waveform means what? Basically it is triangular waveform. Okay, this is sawtooth waveform, triangular waveform, or you can even say ramp waveform. Then I think one of you said that it is used for measurement of different signal. Measurement of different signals, or you can say measurement of voltage or what frequency. Okay, all those things we can do. Next, what we can do? What we can do basically analysis of what? Analysis of waveform also. How we are going to see? Basically we can compare one signal with another signal. Okay, so that is basically what it is, your analysis of waveform. That also we can do. Okay, so CRO, it is also basically a very fast XY plotter. Can anyone tell me what is this XY plotter?
The plotting of waveform like across the x and y axis. For x-axis, we can take time.
Are you using two devices, Nitish? Huh?
Yes, sir. Yes.
So do one thing. You mute one of the device, means just do this. Yeah, mute one of the devices. See, even I am using two devices. You can see one is mobile, one is my laptop. So I have kept this mobile on mute. Mobile, I use it for just for seeing your messages. Okay. So mute one of the devices, or else there is this noise. You can see, I will show you. See, the moment I are you seeing the disturbance? So same thing is happening. Mute one of the devices.
Yes, sir. Now it is fine.
Now it's fine. So CRO is also a very fast XY plotter. Now what do I mean by XY plotter is that it can display one signal over another signal. Display one signal with respect to another signal. See, usually when we plot any signal, what happens that your x-axis is basically time. Okay, like a sinusoidal signal, if we plot it like this. So this is what one of the running parameter or your running variable is always time, or x-axis is time. Now what happens if I want to plot a signal, suppose where running variable or x-axis is not time but a different signal. Now we are going to see how to plot that signal. Okay, it's a very simple signal we are going to see. So at this time, keep on writing whatever I am saying, because the CRO, it is a very theoretical topic. It's not like Q meter or all the other topics that we have seen that are basically your application based. This is your what? This is your theoretical topic. Okay. So as I think Shishir told that here basically this cathode ray oscilloscope is an electron emitter. Okay, electron emitter. So let me tell you that the basic operation is that what happens, we have some kind of electron emission going on. Okay, at this moment I am not telling how. Electron emission going on, then by certain mechanism what we do, these are your plates. So with certain mechanism, we deflect this electron beam according to our needs. Okay. And when this electron strikes a particular screen, it creates what? It creates your, means you can say there is a fluorescence or there is a light. Okay, light emitted when this electron strikes the screen. Can anyone tell me what is this principle that I told? When electron strikes a certain medium, there is light emitted in the visible region. So we have studied all this thing in your 11th class. If you remember, see, if I am not wrong.
So photon emission.
What?
Photon emission.
Photon emission nahi yaar. Photon emission is something different. Photon emission is what? If suppose you have a surface and when you strike it with an electron of some particular energy, it emits photon. What you said? Photon emission. Photon emission you cannot say because there is no heat involved at that point. See, previously if you have seen the television set, okay, television set, it used to be like, it used to get warm. Okay, it used to get even hot also. So their temperature was involved. So basically you have one electron gun. Okay, electron gun. What it does, it generates electron with the help of a filament which is heated up. Okay, so you generate electron with the help of heated filament, and when this energized electron, it strikes a surface of a particular coating, what it does, it emits photon. Okay, it emits your photon with a particular energy which lies in your visible region, and this is known as cathode ray oscilloscope. Its principle is what? It works on the principle of thermoionic emission. So don't worry, don't need to write now. Later on, when we start with cathode ray oscilloscope, I will tell you. At this moment, I just told you that it works on the principle of thermoionic emission. Thermoionic emission means what? When an electron, which is generated with the help of filament or heating an element, if it strikes a particular screen, okay, particular screen, I am not even telling what is the screen. When it strikes a particular screen, at that time, what happens? Your electrofluoroemissions happens, and that emission is known as what? Thermoionic emission. Any doubts? So this is totally theoretical topic, okay? So don't worry, I will write everything for you, point by point I will write. So today I will discuss little bit about this, and when we go over here, okay, point by point I will open my notes and I will dictate all the things, okay, because there are like 1 to 3 pages notes is there for this thing. And because nowadays this thing multiple select type questions are coming, so that is why we need to even study the theory. Or else last 3 years I never told theory for all this. I told what basically this vertical amplifier did. Here we have probes and cable, what were the equations, all those things. But now we have to study all the theory, because you don't know what multiple select type questions might be asked. So that is why we are studying all this theory. Okay, so CRO is what? CRO is a very fast XY plotter. Now, we haven't studied mechanical devices yet, but mechanical devices, we have inertia. Now, I will explain how basically this is. Suppose you have a weighing scale, okay, like the vegetable sellers use. Weighing balance, okay. So tell me one thing, if continuously, suppose this is my, here I put the standard weight bars, and here I am putting vegetables, okay, I am piling vegetables up. Now tell me one thing, I have given you weights like for 1 kg, then 500 gram, 250 gram, 125 gram, all these weights I have given. Next will be what? 62.5 gram. I have given you weights. But tell me one thing, if I continuously change the weights over here, can you balance the scale instantaneously? Tell me yes or no.
No, sir. Instantaneously, we cannot balance.
You cannot do. Why? Because this weight over here has some kind of inertia. Okay, it has some kind of inertia. So the moment if you add new vegetables over here, this will go down, and even if you try to counter it, this scale, it might swing like this. Continuously it might swing. Okay, you cannot balance it immediately. Why? Because these weights have some kind of inertia. Okay, so that is why you cannot balance it. But okay, so what is this inertia? What is inertia? See, I am teaching you 11th, 12th physics, okay? So now
Newton's first law.
What is Newton's first law?
Any object, if it is in motion, tries to remain,
Yes,
to be
very
in motion,
good,
and if it
very
is an
good.
object.
Yeah, chalo, very good. So whenever an object, it is in motion, it tries to remain in motion until and unless I applied what? I apply some external force to it, okay? Usually, if you push a body, or means if you push a body, it will continuously try to remain in motion only, but due to your friction, what happens? It means it comes to halt. Okay, fine. So this is about inertia. Now, inertia is caused due to what? Inertia is caused due to what? It is caused due to the mass of the body. Okay, mass, not weight. Not weight. Mass of the body. Okay, mass of the body. So when your body has a higher mass, suppose you are, if you want to stop a truck, a moving truck, can you do that? You cannot do that. Why? Because the truck has a very high mass. You cannot stop truck. समझ रहे हो मतलब? If you try to stop a bus like Superman, You might be squashed like a fly. Okay, so don't ever try to do that. But if there is some kids bicycle, okay, small, that tricycle thing, you can't stop it. Why? Because that has very low mass or very low inertia. Now all these things, all this mechanical instrument, they have high mass, but electron, it has very less mass compared to mechanical products. So that is why there is low inertia effect. Now low inertia effect, suppose I will give you one more example. Now this is what? This is your 250 gram, or even you can say this is your 1 gram, some object is there. And then we have one electron. What is the mass of electron? Is it, please check, 9.1 into 10 to the power minus 31? I exactly don't know.
Yes, sir, it is. Yes, sir.
Is it?
Yes, sir.
Okay. So kg. No, not kg. I don't know exactly the unit. Even I have forgot. I don't
kg,
know.
sir.
It's in kg.
Kg only? Okay.
Yes, sir.
So then it's not mass, it's weight. Now even I am getting. Then what is the unit of mass? It's moles. Okay, let us forget this. Okay, even I have forgotten my 11th physics. So I know maths very well, but physics I know, but little bit. And maths, sorry, chemistry totally I have forgotten. If you ask me what is simple things, also I don't know about chemistry. Okay, so fine. So this thing you can see, this is 1 gram, or you can say this is 10 to the power minus 3 kg, and this is 10 to the power minus 31 kg. So if I accelerate this mass with the speed of light, okay, if I accelerate this mass with the speed of light, it will have very high momentum, and due to that high momentum, it will have very high inertia compared to this electron, because its mass is very less. So what happens if you want to stop this mass, sorry, mass I am telling, if you want to stop this mass or body, you will require very high amount of energy. But if you want to stop or deflect this electron, you will not require that much energy compared to this. So that is why this CRO is based, means it has very low inertia, and due to low inertia, what happens basically, I can plot or change the signal which is changing rapidly. Okay, it can plot a signal which has very high frequency. Why? Because a high frequency signal, it is going to change very fast. Okay, it is going to change very fast, and when it changes very fast, its magnitude is changing very fast. So even your corresponding energy that is being supplied to the electron, which is hitting your this screen where your this signal is going to be plotted, that electron basically, it is also going to change very fast. See, basically what happens, a ray of electron, see, if this is your electron, basically it passes through some plate, and these plates are going to basically deflect. Now the voltage on these plates are basically directly proportional to the magnitude of voltage or current of the signal that I am plotting. So basically when this hits the screen, these electrons are basically plotted like this. Okay, and you can see this image, that basically this is the image of this signal. Are you getting the point? Are you getting the point what I am trying to say?
Yes,
See,
sir.
if there was a CRO present, it was very easier for me to make you understand what is happening. But as we don't have a CRO with us, so you have to understand it this way only. Okay. So basically, electrons are hit on the screen. Okay. Now you might say, sir, means how is this much electrons are hitting the screen and we are seeing a continuous waveform? So I will tell you, basically there are trillions of electrons ejected in your 1 second to hit the screen. So that is why basically you see this as a continuous waveform. You see it as a continuous waveform. But if there is some provision where you can see this, means the sensitivity is in the trillionth of a second, you might see that even this sinusoidal waveform, it is like this. But as there are, means we don't have that high sensitive CRO, we see it as a continuous waveform. Okay, is this clear? Is this clear? Any doubt?
No, sir.
वॉइस से तो नो अच्छा नहीं लग रहा है. इट्स लाइक सर नो सर, यू
No, sir,
डिडंट.
it's clear.
ओके, चलो कोई बात नहीं. So oscilloscope can measure two or more inputs simultaneously. So basically we have what? We have dual channel CRO. Now even we have three channel CRO also. So what does this dual channel CRO does? It can measure two or more inputs simultaneously on one single screen. Okay, one single screen you can measure two or more inputs. Have you seen that? Have you seen dual channel? Okay, chalo, good. So next we have to see this cathode ray tube. Okay, cathode ray tube. What is this cathode ray tube? So cathode ray tube, or this consists of mainly 4-5 parts. Okay, 4-5 parts. So one by one, let us see those parts. So first is what? Electron gun assembly. Now what is this electron gun assembly? So electron gun assembly is basically your this much part. Okay, first let me write all the things. So first is electron gun assembly, then is your deflection mechanism. Okay, deflection mechanism. Then comes your fluorescent screen. This is your fluorescent screen. See, even this thing CRT, I haven't drawn it completely. There is PDA also even here. Post deflecting accelerator, all those things are there. So we will discuss those when we study CRO. Okay. At this time, I am just simply discussing what is cathode ray tube and the basic mechanism through which this cathode ray tube operate. Okay. So fluorescent screen. Then we have this glass envelope, outer covering. Okay, and what is the last one? Even I forgot. Yes, this pins. Okay, base. Anything else we have? Fine. So this is this much we have. So now, first this glass envelope. You can see glass envelope is basically the casing in which this whole apparatus is set up. Okay, this whole apparatus is set. So this is the glass envelope. Now what is this pins? So pins are this one. Okay, where we supply very high current, or sorry, high voltage to basically generate or develop electrons. Okay, a stream of electron. Now how do we do that? So basically we have this pins. So this comes under your base only. So these are your pins. Now these pins supply current to your this heater. This is your heater. Okay, this is your heater. So in this heater, basically we generate heat to generate electrons, a stream of electron, a beam of electron you can say. So we generate basically a beam of electron like this. Okay, a beam of electron. Now how is this beam generated? Basically electrons is emitted in all the direction. Okay, beam is emitted in all the direction, but with the help of what? We have one more apparatus over here. This element, it is what? It is known as your grid. This grid, basically what it does, it channelizes or it creates a fine beam of electron, which is going to hit the screen. Tell me, up to this point, is it clear? Any doubt? Okay, any doubt? Fine. Now, if you see, now you might ask, what is this, sir? What is this? So these also basically serves as a grid, but they have different purposes also. They have different purposes. What is that? This one is your pre-accelerating anode. Okay, pre-accelerating anode. Okay, now what is this pre-accelerating anode? Okay, tell me one thing. This is your screen. So physics, even I forgot. Photoelectric effect, let me remember. No, this was not photoelectric. Photoelectric effect stated that E is equal to E naught plus half mv square, if I am not wrong, where E is equal to h nu and this is equal to h mu naught plus half mv square. Even the terms I have forgotten what these were known as. What was that effect? I forgot. It's okay. Hello, I will explain it in an ad hoc manner. See, tell me, there are two electrons, okay? This is electron 1, this is electron 2. Now this is your screen. Now this electron has higher velocity. Let us assume this is v1, its velocity is v1, and electron 2 has velocity v2, where v1 is greater than v2, and both of them are hitting the screen. The moment electron hits a screen, hits this particular screen, fluorescent screen, there is what? There is electroluminescence. Yeah, you can say there is light produced. So which of the electron is going to produce more fluorescence? Electron 1 or electron 2? Yes, very good. Why 2? Why 2? Obviously it is going to be 1. Why 1? Because the electron that has more energy. Okay, tell me one thing. So means you might have played different video games. Okay, different video game. So this RPG type games means shooting type, rapid, what I don't know, even I don't remember, shooting games. So tell me, which gun causes more damage, a small revolver or a pistol or a big assault rifle? Which causes more damage? A rifle, big one. So similarly here also the same thing is happening. The electron, why big rifle you told? Because the bullet that is coming out from a big rifle, it has more velocity. Okay, it has more velocity compared to the small revolver or a pistol. So it will cause more damage. So similar way, this electron, it has more velocity. So when it hits the screen, it will cause more luminescence over here compared to this. So basically this pre-accelerating anode, what it does, see, basically electrons were emitted. Now what happens, some of the electrons it might hit at this position at the edge of this. Now this is also going to transmit. Some might hit at this edge, so these are also going to transmit. So what happens, energy reduces. Okay, velocity, kinetic energy of this electrons, they basically decrease. So I have to maintain a constant. See, you don't want a signal, which is flickering. Means flickering means what? The electron that is at this particular instant, it has some different velocity compared to this one, this one. You don't want that. Why? Because I told you the velocity of electron is directly proportional to the display, means the brightness of the display, I should be saying brightness of the display. So you don't want a signal which is continuously flickering. Okay, why you don't want? Then you won't be able to analyze the signal. So you want a constant flow of electron or a constant beam of electron which has what? Which has same velocity hitting the screen. So that is why this pre-accelerating anode is required. So what it does, it accelerates all these electron beams which is flowing from this grid. So its main purpose is to what? Its main purpose is to accelerate the electrons which are going to hit the screen. Tell me, is it clear? Is it clear?
Yes, sir.
Nitish, any doubt? Okay. Next, what we have? So this one is your focusing anode. Now, what does this focusing anode does? So focusing anode, what it does, it basically, now this one, basically you can adjust the value of the positive voltage that you are giving to this focusing anode, so that you can either, suppose if you, this is the signal that is displayed on the screen. Now if suppose you want to do what, you want to just magnify this part. Okay, you want to magnify, or I shouldn't be telling magnify, you want to intensify the display of this much part. Okay, there is some noise or there is something, what you want to do, you want to intensify, I am telling intensify this much part only. So what you are going to do, you are increasing, means there will be some knob for manipulating this focusing anode, where you are going to change the voltage that is being supplied to the focusing anode, so that what happens, it focuses more on this particular part. Okay, it focuses more, so that you get one intensified this much part of the signal. Or even what you can do, you can even intensify the whole signal also. It is up to you whether you want to intensify a certain part, or if you want to intensify the whole signal. So that is done using what, that is done using your focusing anode. Basically it focuses one particular part or the entire signal on the screen. Tell me, is it clear? Is it clear? Next, what we have? Next, this is simple. This is your accelerating anode. Now, this is the final anode that we have over here. Okay. After this much part, now there are different apparatus here also present. We are not discussing that because that will not be asked in your exam. Your CRT is not this much simple that you have three things over here, two plates and bus, itna hi hai. No, it's not like that. There are more things, complex things over here. So we are not going to discuss. Okay, can anyone tell me what is the medium inside this tube? What is the, yeah, vacuum, or there is one more thing. Have you heard about inert gas or noble gas? Noble, huh?
Yes,
Yes.
sir. Yes, sir.
Okay, so remember that xenon, and what we used to have, chemistry to bilkul zero. Okay,
Argon.
yes, argon, all those things. Okay, I don't even remember. So inert gas means even you can, means last year also I didn't discuss all these things because there was one question, and thankfully I had discussed that point while I was discussing over here last year in instrumentation. You can see there was one simple, very theoretical question was asked. It was that which of the plate, this is horizontal, this is vertical plate, which causes X deflection. Means there are two axes, this is X, this is Y. So out of this, which plate causes this deflection? It was asked, and I had discussed it. Okay, I had discussed this over here in a very rough way. So two students were present in instrumentation, and I think three were in electrical. They all attempted that question because it was a straightforward question. So now that is why I am discussing all the theory. Okay. Okay. So this accelerating anode, it is the last anode that we have, which is going to accelerate this beam of electron, because as I told you, there are different mechanisms present over here which we are not studying, but it is going to reduce what? It is going to reduce the velocity of this electron beam. So this is the last anode which is going to accelerate this electron. After this, after accelerating anode, basically it is going to pass through your deflection mechanism, and this much part, this whole part up to this point, combinedly it is known as electron gun assembly. Okay, this whole part is known as electron gun assembly. Now, if there is a theoretical question asking what are the parts that are consisting of electron gun assembly, you should be telling that electron gun assembly consists of pin or heater. There are grids, there are anodes. Now they might ask you what are the different types of anodes. So you should say pre-accelerating anode, focusing anode, and the last one is accelerating anode. So all these things you should be known. Okay, is it clear? Is it clear?
Yes, sir.
Now next we have is what? We have your this one, deflection mechanism. Okay, deflection mechanism. So deflection mechanism, basically there are two types of plate. Now, do you know the symbolic representation of CRO? Means if I am not wrong, wait a second, let me cross check once. So one book I had read, it's okay. Yes, you can see. So this is the symbolic representation of not CRO. Sorry, I am sorry. This is the symbolic representation of CRT. Okay, this one. This one. This is the symbolic representation of this whole thing that we are seeing. So basically there are two types of plate. So just I wanted to confirm once because you should be knowing what we are studying. So there are two plates. This is what? This is your vertical C. This is very confusing thing. Okay, very confusing thing. This is your vertical. In some book it might be written vertical deflecting plate, or this plate is basically like this. See, I will show you in 2D. So basically what happens, this electron beam passes from here and it gets deflected according to the voltage. So can you tell me, is this plate kept vertically or horizontally? Vertically or horizontally?
So horizontally.
Horizon.
Horizontally it is kept. So sometimes it is also said as horizontal plate. So this is quite confusing. Even I was confused. But I will tell you why the name vertical deflecting plate. I will, in a moment, I will just tell you. Let me first write why this is confusing. I will tell you. Okay. So you can see this is known as vertical. In some textbook, you are going to see that it is written as vertical deflecting plate, and in some textbook, it might be written horizontal plate. Okay, horizontal plate. Now, I am not telling what this plate is doing. First, just understand. Then I will do what? I will make you understand what these things are doing. First, let us just see. So we are going to see this. Now, next, this plate. These plates are known as what? These are known as horizontal deflecting plate. Horizontal deflecting plates. And you can see I have even drawn this plate in your 2D diagram, or let me draw it once again for you. So these plates, it is like this. So let me try to. So this is one plate. Okay, sorry. So drawing 2D diagram for representation of 3D, it is an art, I will tell you. I have seen few people in my life who can draw very well. Very means really very well. One of them is my teacher. Okay. He draws very nicely. Means if you just tell him, sir, can you draw this thing? He draws very neatly. Okay. Means I have seen him like he used to draw things very good. And if you ask, sir, have you seen anyone else? So my father, he also draws very well because he's a mechanical engineer. So he draws all these diagrams very well. So when I was in my school, I used to give him all my assignments to draw. So basically, if you are from mechanical background, you can visualize things very well. Now, I won't say this because I have seen different students also, they can visualize, even teachers I have seen. I try to copy them. Means I don't understand exactly how they can visualize things. See, now I am trying to draw this thing, but I am not able to. So basically, these are two plates, okay? Hopefully, you are understanding. These are two plates. So you can see these are kept vertically. Now, electron is flowing in between these two plates. So, can you see this plate that these are basically what? These are kept vertically or horizontally?
Vertically.
So, why are they said horizontal deflecting plates? We are going to see it in a few moments. So, this is also known as vertical plates. Now, basically, these two plates only actually can do what? It can display any kind of signal that we are giving to this CRO or specifically to this CRT. Okay, it can display. Now, there is basically this phosphorus screen or phosphorus. Phosphorus, I think, yes. Aquadag. Phosphorus screen. Now this phosphorus screen, what basically it does, the electron that is being hit over here, okay, it creates one electroluminescence. That means what? Basically the moment electron hits, it emits one photon which is in the visible range so that we can see a speck of light over here. Okay. Tell me, is this clear up to this point? Any doubt? Any doubt? If any doubt, let me know. So note this quickly. Have you noted everything, whatever I have told you? Noted? So note, quickly note. So my teacher, he draws all these diagrams so well. Means I sometimes think, means what will happen if I can just copy how he draws. Means my handwriting is okay. Okay, everybody can understand, that is fine. Means I have seen few teachers who write very bad. Okay, very bad. And it doesn't look good because if I am teaching, I shouldn't be the only person who should understand my writing. But my diagram skills, like I draw, it's not that good. Not at all good. Noted? Tell me yes or no.
Yes, sir.
Okay. So now let us try to see basically about these two things and how different waveforms are plotted. Okay. So let me just give me a minute. Let me first visualize myself only. Okay, fine. So I will try so that you are also able to see things. Okay, so one by one, let us understand what is happening. Okay, so first understand, and then we are going to see. Simultaneously, should I draw? So it's okay. Okay, fine. So we have one what? First, let me make you understand what this vertical deflecting plate is doing, or why is it called horizontal plate. Now you can see why this is called horizontal plate, because these plates are kept horizontally. Suppose if I want to plot this signal, okay, please understand what is happening. Suppose if I want to plot this signal, so here you can see this is your y-axis, this is your x-axis. Now basically there is a stream of electron, fine stream of electron that is entering this plate. Okay, we have the screen. At this moment I have not drawn your horizontal plate. I am just talking about this screen, and this screen is what? This is the side representation, this is the side view. If I want to draw the front view means what? I am seeing this apparatus from here. So basically the plates will look to me like this. These are the plates. I am looking from this side. Suppose this is my eye. I don't know, it is not looking like eye. Okay, so if I am looking from this point, so you can see these two plates, it will look to me like this. See, if you understand this, then in the next class only CRO will be over, or else it will be very tough for me. See, this is your plate. So I will keep the representation same. So here plates are in black color. Let me draw the screen in your green color. This is your fine blue color, means fine beam of electron. Okay, so now this is the, if I am seeing this apparatus from this side, what will happen? So these two are your plates, and your screen, let us assume it looks like this. This is your screen. Okay, this is your screen, or we can even draw the screen in 2D. So So this is how one CRO screen looks. If you have seen, there are different grids over here. Okay. It's just I am showing. I will erase this, but you should know how a screen looks in a CRO. We have different grids, equally spaced grids. Okay, like this we have. Tell me, up to this point, what I am trying to say, is it clear? Okay, fine. So now look, I will be erasing this part. And now I am drawing the screen in a simple way. So this is my screen. Okay. And we have plates. So plates, basically assume that your plates are out of the screen. So this is my screen. This is my laptop screen. Okay. And in which I have assumed that this is my CRO screen. So your plates, suppose they are 10 centimeters away from the screen. 10 centimeter away from your laptop screen, kept in this position. And if you look it in your 2D diagram, so it might look like this in your front view. Okay, it might look like this. Okay, or you can even, means they are basically like this. Okay, so this is the screen. See, understand very carefully now. So these two are what? These two are horizontal plate, and this is my screen. Please tell me, up to this point, Nitish, Shishir, both of you clear? Are we on the same page or not? If there is any doubt, please let me know.
Sir, if this just one query, this green part is our CRO screen, right?
Yes, CRO screen. This is the CRO screen.
Okay, sir. Yeah.
Okay. So one thing I want to share, that in this CRO screen, this is your x-axis, this is your y-axis. Okay. Now see very carefully. Basically, this plate is kept like horizontally, but why am I telling it vertical deflecting plate? See, basically, if I pass one electron, okay, this electron is passing. So in this screen, basically this screen, so just give me a second. My only aim is that you guys understand. If you are able to visualize things, then it won't be difficult for me. In this screen, basically this is the same screen that I have drawn. Tell me, are you able to see that this is y-axis, this is x-axis? Please tell me. So this is the same screen. See, if this was your online live class, sorry, offline class, it would have been very simple. I would have asked any one of you to come hold one page and I could have explained it. Tell me, can you visualize that this is the screen? This is your x-axis, this is the y-axis. Now, tell me, if I vary the voltage, okay, let me assume I am varying the voltage in this plate, okay, in this plate, let this be deflecting voltage VD. In which axis is this beam going to be deflected? In y-axis or x-axis? Means please write y-axis or x-axis. Acha, y-axis you are telling me. Y-axis. Nitish, have you understood that if I give electron, basically either this electron, it can move upside like this. It can move either upside like this. It will strike at y-axis, or it can move down like this and it will strike over here. Okay, it is going to strike like this. So if this is my sinusoidal wave, let me assume this is A, this is minus A. So with the means if I give just this signal, if I give this signal to this plate, this horizontal plate, what will happen on the y-axis? Basically the signal that I will see, it will be simply what? Can anyone tell me? It will be simply what? See, if you give this signal, okay, now simply if you are giving this signal, there is no x-axis. I am telling, I haven't discussed anything that how to move this waveform in x-axis. I haven't told you. I just told that I gave this signal to this plate. You can see basically it has the capability, this plate only has the capability to do what? To deflect this electron beam either up on the y-axis or down on the y-axis. So basically what will happen, the signal that is going to be emitted, means that I am going to see on the screen. See, look, I am taking few displays over here. So this, let this be 1, this be 2, this be 3, this be 4, this be 5, this be 6, this be 7, 8, 9, 10, 11, 12, 30. So what will happen? See, this is the y-axis, this is the x-axis. See, now when I give this value of voltage to this VD plate, so what it will do? Basically this first electron, so electron I am using blue color, it will strike at this point. So this is my first electron. Now second, you can see it has a voltage magnitude higher than the first, so second electron will hit over here. Now third, it has more. This is third. Now fourth, it has some more, so it will strike over here. Now fifth, you can see it is exactly the same as 3, so this will be fifth also. Sixth, it is same as 2. Okay, seventh is same as 1, so here will be 7th. Next you can see is 8, so 8th is over here. Next you have 9th. Next you have 10th. Then you have 11th. So 11th you can see once again it is same as 9. 12th is same as 8th, and 13 is same as 7 and 1. Not 7. Yeah, this is 7 and 1. Okay. So can you see this or not? So basically all you can see is a straight line on the screen. and this straight line, it will be continuously oscillating between these two position. Means what? It will be just like, see, once this beam will go up, then it will come down, go up, again come down, up, down, like this it will go on and on. So for a sinusoidal representation, if you just give it to the horizontal deflecting plate, you are going to see like this. Please tell me, is it clear? Is it clear or not?
Yes, sir.
Is it clear? So that
Yes,
is
sir.
why this plate is known as what? This plate is known as your vertical deflecting plate, because it only has the capability to deflect the signal vertically. Okay, it has the signal capability to deflect the signal vertically. Now see very carefully, very carefully. If I made one mistake, okay, it's not that big of a mistake, we can rectify it. Please don't draw anything at the moment. First you understand. If you understand, I will give you 5 minutes to just write whatever you have understood and draw the diagram also. Not 5 minutes, 2-3 minutes. Okay, so I'm going to erase this part also. Okay, first write up to this point, write it. See, if you have understood this part, then this electrostatic deflection, it will be very simple now. So whatever I have explained, please write it down. Written? Tell me yes or no.
Yes, sir.
Okay. So now let me show you what vertical plate or horizontal deflecting plate. Then we are going to combine both of them. Okay. See, now I remove this part. Okay, I remove this. Okay, fine. See, now what I am giving, I am not giving the same signal this time. Okay. To this plate, if suppose, let me give this signal. So I should have written it like this only with T, and this signal is given to this vertical plate with respect to T. Okay. Please understand very carefully what I told. This signal was given to what? This was given to your horizontal plate. So I will write also over here horizontal plate or vertical deflecting plate, and this signal with respect to time is given to your what? It is given to your vertical plate or horizontal deflecting plate. Please tell me, is it clear? Is it clear? Horizontal deflecting plate. Now when you see this horizontal deflecting plate from this side, what will happen? You are going to see it like this. Okay. Now I have given this signal. Okay. I have given this signal. So this is the x-axis, this is the y-axis, this is the positive side of x-axis. So let me write also positive side, this is the negative side of x-axis. Fine. So now you can see basically this signal, sorry, this plate, I am giving this signal. So let me assume this is point number 1, this is 2, this is 3, this is 4, this is 5, this is, अरे 5 थोड़ा इधर आ गया. See, I am doing something else also along with this. 5 should be over here. So this is 5. So this is 6. Sorry. This over here is 6. This is 7. Similarly, this point is going to be 8, 9, 10, 11, 12, and this is 13. Okay. So these are different points with respect to which electron is going to be emitted. Now see what will happen when I emit, means corresponding to this first point, the electron will strike over here. Tell me, is it clear or not? It will strike over here. Corresponding to the second point, it will strike over here. Corresponding to the third point, it will strike over here. Corresponding to fourth, it will strike over here. Corresponding to fifth, it will strike over here. For 7th, 8th, 9th, 10th, it will strike over here. If you see in this side, so this simple, this signal, it will look like this. Tell me. This is just one cycle. Now for different cycle, once again, this is the signal. Once again, the signal will start from here and it will go up to this point. Once again, the signal will start from here, go up to this point. So for this is for one time period. If I draw it for multiple time periods, it's continuously going to start like this. Okay. And if the frequency is very high, you can see it will form a continuous signal like this. Okay. Tell me, is this clear or not? Tell me yes or no. Is it clear? So now this is basically your what? This is your horizontal deflecting plate. Why? Because it is deflecting your electron beam in the horizontal side. Okay, horizontal side means what? Either when your electron beams it enters over here, either it can get deflected to this point or it can get deflected to this point. Okay, so now with the help of this two plate, I can deflect an electron beam either in the y side or x side. Combinedly I can do. Please tell me, is it clear? Is it clear? So note it down quickly, and then we are going to combine now. Noted? Okay, fine. So now we are going to combine these two plates. We are going to combine these two plates to see the exact signal. Okay. So I will do it here itself. Okay, I will do it in here itself only. So now let me introduce both the plates. Now, have you understood means what is going to happen now? So these two is what? This is your horizontal plate. So you can see horizontal plate is going to deflect in y-axis, vertical deflecting plate. And these two are what? This is your vertical plate. It is going to deflect in your x-axis. Okay. So horizontal plate was like this. So now I am not drawing that much. You have understood. So now see, basically this signal, this is given to horizontal plate and this signal is given to vertical plate. Now what will happen? See, both the points 1, the electron corresponding to both the point 1, it will strike at this point. Okay. It will strike at this point. Now see, the second point, you can see what will happen. Both the voltages are acting. Okay, both the voltages are acting and corresponding electron to both this point, it will get deflected and it will strike over here. Not over here, means somewhere over here. Okay, because why? If this signal was not present, second electron would have striked over here. Okay, it would have striked over here. But as this is present, if this was absent, then second electron for this one, it would have striked over here. So basically it will be the resultant of these two, and resultant will be somewhere over here. Similarly, for third one, if this signal was not present, it would have striked over here. Similarly, if this was not present, only this was present, it would have striked over here. Now there will be a resultant of this two, which will be somewhere over here. Next is the fourth one. Similarly, this will strike over here. Then fifth, sixth, seventh, eighth, ninth. Okay, 10th one is the maxima. 11th, 12 and 13. Okay, so now you can see basically there are millions and trillions of electron in between these 2 points also. So basically it will look to you like a sine wave which I have taken. Tell me, is it clear? Is it clear? All of you? So did you understand basically what is the purpose of horizontal plate and vertical plate? Why horizontal plate is called vertical deflecting plate and why vertical plate is called horizontal deflecting plate? Did you understand? See, basically the plot that I have made, this is your YT plot. Why? Because you can see the x-axis is corresponding to time. Okay, x-axis is corresponding to time. But if instead of this signal, I had taken one more sine signal over here, suppose if I had taken a sine signal that looked something like this. Now my diagram is very messy over here. If suppose I had one more sine signal that looked like this, now I would have got XY plot. XY plot. And with the help of this XY plot only, we are going to see the Lissajous pattern. Okay, Lissajous pattern. So at the moment you just write, we are going to see XY plot also, but note point you can write that basically this is what is known as YT plot. In YT plot, remember always that the signal that we are giving to your vertical deflecting plate, it is a ramp signal. It is a ramp signal. Always remember in YT plot, this x-axis, whatever we give to your vertical deflecting plate, it is basically a ramp signal. Okay, a ramp signal. Tell me, is this clear? Please note it down. Any doubt, Shishir, Nitish? Noted?
Yes, sir.
In this the deflection plate that we have used,
Pardon, I
how is
couldn't
the
hear. Once again, repeat.
sir
Repeat.
in this the deflection plate that we have kept, how does this how is it oriented, like one upon the other or like one following the other?
One following the other. One following the other. You can see it over here. Okay. But when we see it from this point, suppose if I see the plate from this point, okay. So you can see at that time I will see it like this only. Okay. So that is why you can see, but it is not one above other, it is one beside other. Okay. One followed by other one. Is it clear? Did we understand? Noted? Noted? So next we
Yes,
have
sir.
is what? Tell me, Shishir, any doubt?
No, sir, noted.
Okay. So next we have is what? Electrostatic deflection. Okay. Electrostatic deflection. Here I have taken what? Here I have taken the horizontal plate. Okay. Horizontal plate I have taken. This is your horizontal plate. Now to this horizontal plate, we are going to apply different voltages. Okay. Different voltages you are going to see. First voltage is what? It is your VD. So to this plate, I am giving VD. Now what is this VD? VD is basically your deflecting voltage. Now this you have to understand, this is mathematics. Deflecting voltage. Okay. Now before deflecting voltage, you can see basically this is coming through this accelerating anode. Okay, accelerating anode. So basically this accelerating anode is what? This is also giving some kind of voltage due to which this electron is being accelerated. Tell me, is it clear or not? Is it clear or not? So VA is what? VA is your accelerating or pre-accelerating anode voltage. So let me write it as pre-accelerating anode voltage. So I will denote it somewhere over here, VA. Okay, pre-accelerating anode voltage. So one thing I have made a mistake. See, now you might ask, sir, why is this deflection starting from here? Why not from here? So I will tell you why. See, basically, the deflection, the moment this electron beams enter over here, so I will erase this part, okay? So don't draw this in your diagram. This is just for the sake of understanding. See, the moment this electron enters over here, what happens? This electron also has inertia. So immediately it cannot, means like it is going like this. It cannot turn like this. No, it will not be like this. See, this I have taken is the ideal case for making our diagram. But practically the deflection is like this. Sorry. Okay. So what I have done, basically, I have assumed, or what you can say, I have linearized this curve. Okay. I have linearized this blue curve. This blue path is actually the path followed by the electron. So you might say, sir, why is it deflecting directly from here? So I have done what? I have linearized this path so that I can get one proper equation for your this D. Okay, this is the deflection that is happening in which direction? It is happening in your y direction. So that is what I want to find out. Are you getting my point? Are you getting the point?
Yes, sir.
Okay. So I have erased this. You can also make one separate diagram somewhere over here and you can write this point. So later on, you shouldn't feel like, sir, what is happening over here? Okay. Okay. So now let me mark few more points. So, okay, so this is LD, fine. So I will write what? Let this be X. Or this much part, let me write it as X. Okay, this is X. This much part is Y. Okay, this is X, this is Y. Anything else that I require over here? So this should be plus minus. The small d is basically the distance between the plate. D is the deflection from the mean of the screen. LD is basically the distance, means the your horizontal distance of the plate, and this capital L is basically what? From the mean of the plate, from where the maximum deflection is occurring to your this means your screen. Okay, so anything are you not understanding over here? So now I will start proving. Tell me, up to this point everything is clear? So after this, what we have? Deflection sensitivity. Okay, so deflection sensitivity, we will keep it as the last topic. And after this, the effect of beam transit time, frequency limitation, time based generator, all these things we are going to see tomorrow. Okay, tomorrow also I will be keeping one class. Okay, tell me, up to this point, is it clear? So now let me start proving. Okay, tell me, is it clear? See, basically, I will explain you one thing. There is a loss of potential energy when electron moves from your cathode to your accelerating anode. Means what? This is your cathode. Okay, this is your cathode. Now when basically when your electron is traveling from here, hopefully you have made this diagram. Now it will start to get even more complex because I am continuously drawing on this diagram only. See, basically this is cathode. So there is some loss in potential energy when it is moving from here to here. Do you agree to this or not? Do you agree to this or not? Now what is electric potential energy? Electric potential energy.
So work done from one charge to another point.
Okay. Or if you remember, do you remember this? Charge into the voltage is basically the potential energy. Do we remember this or not? So basically the loss of your potential energy when electron moves from your cathode to your accelerating anode. So this is the last point where we have accelerating anode. Okay, this was the last point where we had accelerating anode. After this I have is what? My deflecting plates. Okay, deflecting plates. So basically, where should I? Let me start writing over here. So start writing. Write the first point, loss of potential energy, or I will write it in the next page only. Loss of potential energy when electron moves from cathode to accelerating anode. It is given by what? Potential energy is equal to Q into VA. Now VA is what? VA is the pre-accelerating anode voltage. Okay, I have already written. So Q is basically what? Q is the charge of electron. So we know charge of electron is E into VA. So this is the potential energy. Now when there is a loss in potential energy, obviously there is a gain in what? There is a gain in your kinetic energy. So the loss in potential energy is equal to the gain in kinetic energy. Do you agree to this or not? Okay, so the gain in kinetic energy now what is kinetic energy? Kinetic energy is equal to half mv square. mv square, tell me, is this clear? Now what is this m? M is equal to mass of electron. What is E? E is equal to charge of electron. What is charge of electron? And mass, I told you, 9.1 into 10 to the power minus 31 kg. Okay. See, now half into m. This V, I am writing it as V naught x square. Why I am writing V naught x square? Because this acceleration is happening in this x axis. So that is why the velocity gained, it will be in which axis? It will be in your x axis only. Tell me, is it clear or not? Is it clear? See, if you guys have any doubt, you can ask me immediately. So now this kinetic energy is equal to potential energy. So which implies half m v naught x square is equal to E. This V is continuously EVA. Okay, EVA, or this velocity in your x axis, it is equal to what? It will be equal to 2 E VA by m under root. I think we have studied this in your 11th class also, modern physics. if I am not wrong. Somewhere in modern physics we have read this. So did we understand up to this point? So this is basically what, so this is the velocity of electron in the x direction as your electron enters the deflecting plate. Tell me, is it clear or not? So this is the velocity when your electron is just at this point, when it is entering this point. Now tell me, is this electron means is this velocity, will it remain constant or will it change? Will it remain constant or will it remain same? Why change? If it is changing, there should be change in your kinetic, means there should be change in your potential energy. Why it should change?
Since it's moving forward.
Tell me. Is potential energy going to change? Is VA going to change? At this point, I am talking. At this point. From here to here, is VA going to change?
No,
Is
sir.
VA is not going to change. Why? Because VA, it has already happened. Whatever was VA, this was the pre-accelerating anode. Here only pre-accelerating anode, this apparatus was over. So VA is not going to change. That means potential energy is going to remain constant. Now you might say, sir, there are a lot of things. Means this electron, it might hit some other stationary electrons over here and there might be loss of potential energy. अरे इतना depth में नहीं पढ़ना है हमको, है ना? We don't need to study in that much depth. According to us, everything is happening in ideal condition. So here you can see VA is not affecting anymore over here. So this velocity in the x-axis, velocity in the x-axis is now fixed. Okay, velocity in the x-axis is fixed. So write one point that velocity remains constant. Velocity remains constant. Why? Because there is no energy, sorry, the energy in your x-axis, or you can even write there is no energy supplied in the x-axis once electron enters this deflecting plates, horizontal deflecting plates. Okay, you can write this much. Fine. So this, let me enclose it in a box. Okay, so now what we can do, let me think. Okay, yes, so do we remember this or not? Means I know there is a negative sign also, but I am taking the magnitude. Tell me, do we remember this or not? What is this?
The electric potential, gradient of electric potential.
Very good. So this is electric field. Electric field is equal to what? It is equal to your dV by dx. We know this thing. Okay. So the same thing I am going to use now, but I am going to write what? Electric field in y-axis. So electric field in your y-axis denoted by Ey is equal to dV by dx, or what is the voltage in your y side? So you can see it is Vd. And what is dx? Dx, you can see it is your small d from the diagram. Tell me, can we see this from this diagram or not? Can we see this? See, this from this questions have been asked. Okay, from this derivation, the derivation that we are doing, there are questions asked. So that is why we are solving this. Tell me, is it clear? Electric field in y-axis is what? Ey is equal to Vd by small d. Okay, Vd by small d. Now, let me ask you, is there any acceleration or change in velocity in the y-axis? Acceleration or change in velocity. Basically, change in velocity is acceleration only. So, is there any acceleration in the y-axis? Obviously, you are changing the direction. See, if there was no, this electric field was not present, this electron would have hit over here. But as we are applying your electric field, so there is a change in direction. That means there is a change in velocity with respect to time happening over here. That means there is some acceleration in your y direction. So acceleration in y-axis. Okay, let me assume that over here what I can do is, oh, okay, yes, so that is what I was thinking. Please stay with me over here. Okay, so what is the force in this y-axis, y direction? There is some force acting in this direction, that is why electron is moving. So that I am assuming it to be as F is equal to m dot ay, m dot ay. But we also know that this force is actually caused by what? It is caused by this electric field only. Why? Because we know F is equal to Q dot E. Do we know this or not? Force experienced by an charged particle in an electric field, it is given by this equation. Okay, so this is actually equal to what? This is equal to Q dot E. Why? Where Q is actually what? Charge of electron. So I am going to write this in the next page. MAY, which is equal to what? Q dot EY. So M into AY is equal to Q is charge of electron, EY is VD by D. Tell me, is it clear or not? Or you can write over here AY is equal to E VD by M dot D. Is it clear or not? Is it clear? So what I have assumed that this is Y, this is X. Up till this point, what I have assumed, you can see there is no deflection in the Y. That means initial velocity in the y-axis at this point is 0. Tell me, initial velocity at this point is 0. After this, we have initial velocity. That is why it is moving in this direction. Is it clear or not? Okay. So we know this expression, physics, means we had 2-3 equation like this. V is equal to u plus at, then one more was v square minus u square is equal to 2as. Okay, so these 3 equations we had in your kinematics. Okay, kinematics we had this 3 equation. So now I am going to apply the same equation. Here you are going to write there was no initial velocity, no initial velocity in y-axis So if I want to see the vertical displacement, see, I have assumed the vertical displacement as y. Okay, I have assumed the vertical displacement as y. So y is equal to half ay. So ay I have calculated, ay t square. Tell me, is this clear or not? So you can put even the value of y is equal to ay is e vd by md t square, means there will be half also. So let this be equation 3, this be equation 2, and this be equation 1. Tell me, up to this point, have we understood or not? Did we understand? If you have understood, please note down. I am giving you 1 minute. Please note down. Noted? Noted? Tell me yes or no. Noted. Chalo. Now see, I have y also. Can I get this x? See, in x, basically, you can see, we know what? S is equal to ut plus half at square. Now, there is no more acceleration in your x-axis. Why? Because there is no more energy supplied in the x-axis. Whatever energy was supplied, it was up to this point in the pre-accelerating anode region only. So now there is no acceleration in your x-axis. That means ax is equal to 0. And if I want to find out this, s is actually x, u is what? Initial velocity. So initial velocity in the x-axis, we have found it to be as vox into t. So let me write it over here. X is equal to ut plus half ax t square. So ax is actually 0 and this is vox into t. So t comes out to be x by vox. Where is the value of vox? Under root 2 EA by m. Under root. Okay, so at this moment, let me write it as vox only. So this is equation 4. From 3 and 4, what do we get? Y is equal to half E Vd by Md into t square. So t square means what? X square by Vox square. So this term was in square root. So this will come out 2EVA by M. 2EVA by M. So this will go above. So M cancel, E cancel. So value of Y we get, it is half Vd x square by dVA. Tell me, is this clear? Is it clear?
It should be 1 by 4.
What 1 by 4?
Y equals to 1 by 4 instead of half.
Why 1 by 4?
We have 2 also.
Oh, yes,
in
yes.
B.
Yes. So there is 2 also. So 1 by 4. Okay, 1 by 4. Okay, tell me, is this clear? Is it clear? Now you can see one thing, that I can assume this x. Okay, I can assume this x to be as LD. LD is what? It is the total distance of the horizontal plate. So y, or let me see. First, let me not do this because I need one more term over here. Okay, fine, yes. So now let us calculate dv by dx. What is dv by dx? So that will be equal to 1 by 4 into vd into 2x divided by va into d. So 2 cancel. So dy by dx is equal to half vd x va into d. Tell me, is this clear or not? Now this is very long. Okay. Even I am getting tired proving all these things. Where is this diagram going? Okay. I think it is. Continuously I was thinking, where is this going? I am pressing Control C, Control V, and I am not able to see. Okay. So now from this, can you tell me what is this dy by dx? What is dy by dx? Tell me, Nitish, what is dy by dx?
It depicts the velocity.
No, from look at this diagram at this much point.
Okay, so the slope of that particular.
Very good. Slope. Change in y by change in x. That is the slope. And slope is basically what? Tan theta is equal to what? Half Vd into x by Va into d. Rishit, did you understand this or not?
Yes, sir.
Now once again this is going to be at that point only, so it's okay. I will write it over here. Slope is equal to tan theta, which is equal to half, what did I get, into Vd into x by Va into d. Okay, Va into d, we got this. Now what I can write, see, one more thing I can write from this expression. If you see, what is tan theta? What is tan theta over here?
Y by x.
No. Now look at this much point.
T by.
Very good. Now this time tan theta is actually also similar to d by L. This is your d, perpendicular by base. So I can write it as tan theta. This is actually equal to d by L. Now d is equal to what? D is equal to half Vd into x into L divided by Va into d. Or here at this point, what I can write, that this x is approximately equal to LD. So now replace this x by LD. So D is equal to half Vd into LD into L divided by Va into D. This is very important because this has been asked a lot of times. A lot of times this has been asked in your examination. Tell me, is this clear? Is this clear? Now, this whole equation, we can also write it in terms of VOX. Okay, we can also write it in terms of VOX also we can write. It is up to you. Whichever way you want to write, you can write it. So this is basically the deflection that happens in your y-axis due to this VD. Tell me, is it clear or not? So you can see that this D is directly proportional to VD. Is it clear? Is it clear? Any doubt? So this is what we have studied about your deflection with respect to your deflecting voltage VD. Okay, fine. So this we have studied. Now next and last topic for today is your deflection sensitivity. Okay, one thing, even I don't remember the formula. See, you have to memorize the formula. So there are two options. Either you memorize this formula, okay, or you should be knowing the derivation also, because you don't know what they might ask. They might ask you, what is this gradient? Okay, gradient. So either you can do 10th, means they have given this VD, X, VAD, all those values will be given, and then they might be asking what is your tan theta. So that is why you should remember the formula as well as the derivation that we did. Okay, so today only I will send you the slides also, so that you can note everything down. So let, अरे यार फिर से it is. So this is the deflection that we got. Now out of this you can see LD is constant, you cannot change it. L is also constant, small d is constant. Okay, LD is this, D is the distance between the plates, and L is this distance. Okay, this distance. This is constant. You cannot change any of the following. What all things you can change? You can change basically your, either you can change VD or you can change VA. Okay, you can change VA. Now, basically, what is deflection sensitivity? Sensitivity is what? What is sensitivity?
Deflection in mm upon the input.
What is input over here?
Voltage that we have given.
Yes, very good. So sensitivity is change in output by change in input. Now output change means what? You can see, if this VD, if this input VD was not present, this electron would have striked over here. So basically the change in output is this capital D, and input is what? This VD. So you have to write what? D by VD. This is also very, very important. So now if you write this, so this is what? Half into, means VD VD will cancel out. So this is LD L VA into D. Now sensitivity means what? Sensitivity means for a change in input, you can see the change in output. So if I want to increase the sensitivity, okay, if I want to increase sensitivity, then what should I do over here? Tell me. If I want to increase sensitivity, what should I do? अरे देखो ना यार, यहां पे लिख के तो रखा हूं, आई हैव रिटन एवरीथिंग. Small l of d is constant, l is constant, d is constant, only one thing is variable, that is v of a. So if I want to increase sensitivity, I should decrease va. Now what is va? Pre-accelerating anode voltage. Okay, so if I decrease pre-accelerating anode voltage, what will happen? Can anyone tell me? If I decrease pre-accelerating anode voltage, now this is the time where you connect whatever I have explained. ऐसे हो ना, मतलब थोड़ा तो एटलीस्ट you should be applying some logic. If you decrease VA, obviously your potential energy will decrease. Potential energy decrease means kinetic energy decrease. Kinetic energy decrease means mass of the electron obviously cannot change. Vox will decrease. If Vox decrease, I told you, if you go over here, somewhere I have explained, where was that point where I took two of these things, electron 1, electron 2, one of them have velocity v2, another has velocity v1, where v1 is greater than v2. I even told which will produce more brightness. You guys told me, sir, it will be v1 which will be producing more brightness because the velocity is more. So you can see, the moment I decrease va, these effects are going to take place, due to which the velocity with which electron strikes the screen, it will be less, and due to which brightness of the spot or signal, it will decrease. Tell me, it is clear or not? Is it clear?
Yes, so while the in the derivation part,
Huh?
so we took while the change in potential, decrease in potential energy was increase in the kinetic energy. So that's why from here, if we are decreasing the potential energy, kinetic
That
energy
is
should.
conservation of energy. कंजर्वेशन ऑफ एनर्जी. गजब हो गया मतलब. So this is your water kept overhead, means in a tank. So over here, this is H1, this is H2. H1 is greater than H2. What will be the case of V1? V1 greater than V2, V1 less than V2. Sir, I don't know physics. Third option. I
First
don't know.
option.
So what are you going to say? Sir, here the potential energy is decreasing, so kinetic energy should increase. Are you going to tell me?
No. I got the point now. But because the potential, while the derivation from VA to VD, we were decreasing the potential and kinetic energy was increasing, and now we are decreasing directly the VA. So potential is
Yes,
increasing as well as the kinetic.
yes,
Yeah,
very good.
this was actually I was confusing.
Yes. Now tell me, if I want to increase the brightness, so what I should do?
Can
If
increase
I
the
increase brightness, you are going to say, sir, just now you told me increase VOX. If you increase VOX, kinetic energy will increase. Kinetic energy increase means potential energy is also increasing. Basically, this is the drop in potential energy or the increase in potential energy. Okay. And if potential energy increases, for increasing the potential energy, I need to increase the VA. Now, if I increase VA above certain extent, what will happen? What will happen? Now tell me. See, if you increase VA, what will happen if you increase VA? So this deflection, suppose here this is for a particular electron, this is VA. And for one more electron, let me have VA2, where VA2 is greater than VA1 for the same amount of VD. Now the deflection will be like this. So let me draw it below. Okay, I am drawing it below. So this is for VA2, which has more voltage, okay, more accelerating voltage. So it is going to deflect less. So it will require more VD to deflect. Why? Because the inertia of the electron will be more. Are you getting my point? Are you getting the point?
Yes.
Tell me yes or no. अरे डरना नहीं है. If you didn't understand, let me know. I will explain it once again. Nitish, did you understand? Shishir?
Yes,
Yes.
sir.
So obviously there is a trade-off between these two, sensitivity and brightness. Okay, the more the sensitive the system, brightness will decrease. If you want more brightness, sensitivity will decrease. Okay, so there is actually a inverse relationship between sensitivity and brightness. Is it clear? Clear? So usually sensitivity, if you see, I think just check once. I think it is 0.1 mm per millivolt, and I think what, millivolt or volt? No, it's volt. To 1 mm per millivolt. Please check this value. I am not sure. Please check. Sensitivity, I don't remember. Let us check only.
Meter per volt.
Sensitivity is what? क्या लिखा हुआ है यार?
Meter per volt.
Meter per volt. Okay, meter per volt is also fine, but what is the value? That is not given. Okay, it's okay. I will check it from the textbook and let you know. Since the value is not written, na? That is what I wanted. Meter per volt is okay. I can convert it, but it is not given. Chalo, unit is given only. So that is okay. We will see it in the next class. I will check this and let you know. I don't know exactly what is the value. Okay, so next class we are going to see the effect of beam transit time and frequency limitation. This has never been asked, but it might be asked. It's a very small point and we just need to memorize two formulas. That will be enough. We are not going to derive this. Then we have, because these 2 points, it has been asked in engineering services a lot of time. What is beam transit time and frequency limitation due to beam transit time? It has been asked. So these two, only the formulas we are going to see. No explanation. This is not in our gate also. Next is what? Time based generator. This is very important. And then we have CRO. CRO is basically the cathode ray oscilloscope. Up till now, we have just studied this much part. We have studied this much. Yes, we have seen some aspect of this vertical amplifier, what it is doing. This time based generator also we have seen, that ramp generating function, that was basically time based generator. So few things I have already told you, but still we have to study this also. Okay, tell me any doubt, or else we will be ending over here today.